Thank you. Good afternoon, everyone. As Anu said, I'm Bill Holdsworth. I'm a second-year PhD student in the Department of Plant Breeding at Cornell. And for the last year and a half or so, I've been working with Michael Mazurek and Michael Gloss at Cornell to develop and improve downy mildew resistance in cucumber. So for this afternoon, I'll be talking a little bit about that project and about some of the work we've been doing there. But at the end of the session, I'm hoping to get some feedback from all of you who've had, all of you that have had experience growing cucurbits about this project in particular, and about some of the biggest challenges you foresee in cucumber production generally, or cucumber production specifically. Our research group tries really hard to focus on meeting the needs and addressing the concerns brought to us by organic growers. So your feedback will help us decide where we go next and how we allocate our resources. So with that, kind of a general outline of what I'd like to talk about. I'll first give an overview of the disease, show you some symptoms that we've seen in our field, talk a little bit about the pathogen that causes the disease, and then we'll talk about why it's become a problem after decades of not being a problem. And then I'll talk a little bit about some of the work we've been doing to evaluate some of the popular cucumber cultivars for resistance, and then some of the breeding work we've been doing to develop improved resistance. So here's our foe here, downy mildew. It's caused by an oomycete pathogen, which in a lot of ways is similar to fungal pathogens, but in a lot of ways it's different. And I only mention that because the control strategies for oomycetes and fungal pathogens can be different. And something that might work really well for a fungal pathogen will only work marginally well, or maybe not at all, with an oomycete. But we've, in Tompkins County anyway, we've seen the disease come usually around the beginning of August. And the disease will come in via spores that will be blown in by the wind. They'll land on the leaf of a cucumber plant. The spores will then encyst. And once that happens, the disease progresses really, really rapidly. In 4 or 5 days, we'll have these lesions, these yellow water-soaked lesions start appearing on the leaves. And they're really distinctive. They're very angular, blocky in shape, and defined by the leaf veins. There's not really many other, there's no other disease you can mistake it for. And if you're still not sure, you can flip over the leaf to the underside, and you'll see this kind of gray purplish fuzz on the underside, and those are actually the reproductive structures of the pathogen. And they give the disease its name because it's very downy in texture. So once we start seeing the lesions, it's not very soon, or it's not very long after that we see complete and total plant death among susceptible varieties. These two pictures are pictures I took in our field last year where we had some susceptible varieties growing, and this is just 3 weeks after we first saw one yellow lesion on one leaf in the field. In our group, we compare it to someone taking a flamethrower and just going through the field, just scorching everything. I mean, there's nothing left. The good thing about this pathogen, if there is any good thing, I guess, is that it doesn't overwinter in the Northeast. So it'll come in sometime in the summertime, either from blown up from the south or from greenhouses in Canada or the northern U.S. So as I said before, downy mildew didn't really used to be a problem. For decades, no one really worried about it, in cucumber at least. Part of that reason was because breeders were able to keep up with resistant varieties. Even back in the 40s, they were working on downy mildew resistant varieties with the release of cultivars like Palmetto. And then in the 60s, another really famous cultivar came out, Poinsett. And Henry Munger at Cornell worked for a number of years developing the Marketmore series, which are all resistant to downy mildew. Some of those are popular heirloom varieties now in Marketmore 76. And pretty much everything released in this broad time frame was resistant to downy mildew. And with the use of copper-based fungicides along with growing the resistant varieties, it was never really a problem to control the disease. But around 2003, 2004, we started getting calls from growers saying, we're growing out this variety we planted for years and years and years. Nothing's ever happened, but now it's succumbing to the disease. And it only took a year or two to realize that this was a really widespread phenomenon, that all of these old standard varieties were falling to the disease. And it became apparent to us that a new strain of the pathogen had mutated and had now spread, and it's now spread everywhere, northeast, south, all over the U.S., all over the world. So we took on this challenge of trying to figure out how to reincorporate resistance into cucumber varieties. So what we did first was to find out whether any of the, or some of the most popular varieties that people were growing had any level of resistance or not. Whether they had any left, and whether there were some that might have more resistance than other varieties. So we decided to take these varieties on the right-hand part of the slide here and grow them out. And we grew them in open field and high tunnel environments. It was our thought that maybe the high tunnels would provide some protection against the disease because of the physical structure might obstruct some of the spores, but more importantly, we thought that the controlled environment, the reduced humidity, might interrupt the life cycle of the pathogen. So our initial results were promising. We saw immediately that it was true that some varieties had better resistance than others. The slide's kind of cut off here, but on the lower right-hand side here we have Marketmore 97, and on the top left there is Piccolino. And this was in 2010. This was 3 weeks after we saw the pathogen arrive, and you can see, you know, Marketmore's doing all right. You can see definitely some disease symptoms in there, but Piccolino is pretty much dead. And when we put the cultivars side by side, we saw that a few of the Marketmore varieties were doing better than Piccolino. To kind of orient you to this graph, a 5 is a more healthy plant than a 0 is dead. So Piccolino had 90% loss, whereas Marketmore 97 had around 10%. But what we found was that these most resistant varieties, quote unquote, really just delayed the disease, because these ratings were taken about a month after the disease had first come in. But when we left them out in the field a little bit longer, eventually everything succumbed. So we didn't have anything that would provide what we would really call resistance. We also wanted to look at the yield of these cultivars, because obviously resistance doesn't mean much if you don't get any cucumbers off of the plant. So we took yield data, and what we were surprised to find was that our most susceptible varieties were the ones we got the highest yields off of. And that was simply because Piccolino and Dasher, these two that are up at the top here, produced so much fruit early on that it didn't matter that they were killed right away, because over the course of the season they still produced more fruit than those other varieties with a more extended season. So from this information we decided we needed to improve the resistance of our high-yielding varieties. We needed to improve the yield of our resistant varieties, but in reality we just needed to improve resistance all around. The high tunnel experiment was a little bit of a disappointment. What we found was that the high tunnels did prevent downy mildew more than the open field environments. However, that was more than offset by increased incidence of bacterial wilt in the high tunnels. On the left you can see is one of the cucumbers that's dying to bacterial wilt, and this was a major, major problem in the high tunnels. It was just devastating to the plants there. We just, every week we'd see more plants go down to bacterial wilt. And we've since talked with other growers and have read that this is a very common phenomenon among cucumbers grown in high tunnels, is that bacterial wilt is a real problem. On the right is some leaves with powdery mildew. We found that in the high tunnel, powdery mildew was also more of a problem than in the open field. However, it wasn't nearly as serious of a problem as bacterial wilt was. So we chose to just breed for the open field. We didn't do any more with the high tones based on that information. And as I said before, we wanted to increase the yields of these new varieties we were working towards to match that of Dasher 2 and Piccolino, our highest yielding varieties that we had tested. And we wanted to make sure that the Downy Mildew resistance was as good or better as Market More 97, and that was kind of our baseline. We certainly wanted to do better than that, but certainly no worse. And we chose to focus on white-skinned varieties because we had talked to a number of organic growers who had said that they were interested in us developing white-skinned varieties to fulfill a niche market. So we started with some crosses with Platinum, which is a popular white-skinned variety, and Salt and Pepper, another white-skinned variety that was released from Cornell a few years back. We crossed those with the most resistant materials in our program, and after a few years, several generations, and some good gene shuffling, we came with what I think is some pretty good progress. This picture was taken this year in August, September actually, and you can see on the left, this is 3 weeks after we first had symptom development in our leaves. On the left is one of our susceptible varieties that we had tested earlier, Diva, a very popular, very tasty variety. And on the right was one of our breeding lines that had barely been touched at all by Downy Mildew. It was full of green growth. We did this in replicated trials, and it was fun to see that in all of the replications we had these big groups of our breeding lines that just looked as healthy as can be. And these seem to, they're not completely resistant. We had some symptoms. When you went and looked at them, you could see some of the yellow lesions, but they delayed disease progress significantly. The disease came in the 1st of August, and these plants were still green in October when they were hit by frost. So, you know, if we can only delay symptom development 3 weeks, as in the case of Market More 97, that's not going to cut it if the disease comes in late June or July, as it has in years past. If we can delay it a couple months, then even if it comes in late June, we're still able to harvest through August. And I don't know of any cucumber grower that's doing much harvesting past August. So here is just kind of another graph of some of our breeding lines and some of our checks. This disease rating is a little bit different than the one I showed you before. And on this one, a high number is bad. A high number means lots of disease and death. A low number indicates healthy plants, and this is actually on a log scale. So like a 2 would be 5% death, whereas an 8 would be like 95%. So there's a very, very significant difference between our best breeding lines on this end and our susceptible checks on that side. Salt and Pepper and Platinum we included because they were the parents, 2 of the parents that we used in our breeding lines. Diva was a susceptible check. And if you remember, Market More 97 was one of the most resistant of those popular varieties we tested, but compared to our breeding lines, it looks pretty bad. It's a lot more susceptible than our best breeding lines. So that's kind of where we're at now. We have some great looking plants in the field, and we have a lot of white-skinned cucumbers. We were pretty excited to show growers the progress that we've made, and took them out into the field and showed them these white cucumbers, and then they asked us, well, where are your green cucumbers? And we said, what do you mean green cucumbers? Here's the white cucumbers. And they said, cucumbers are supposed to be green. Where's your green cucumbers? Oh, no. So we've developed these white-skinned cucumbers, but now we can see that there's a big demand for Downy Mildew-resistant green varieties, so we're starting work on that now. And we're continuing to improve flavor. Some of the breeding lines we have out in the field just have magnificent flavor. They're so sweet. You wouldn't even know you're eating a cucumber. Some others you have to spit out before the taste lingers in your mouth. So we're working on flavor. We're still trying to improve yield of our breeding lines. Our breeding lines this summer did not produce as much fruit as some of the other Czech varieties we've had. So we're trying to introduce the trait of gynaece into these lines, which basically means the plants will produce all female flowers, so that we can, or mostly female flowers. They'll produce very few male flowers, so that we can increase production that way. And I guess that's it. I would love to hear what traits we should also be including in our projects, or some other things you'd like to see us work on. But an important part, as always, is to acknowledge the people who helped. On the left here, some undergrads that spent the summer helping out with various things, either doing ratings or evaluations, and then funding sources on the right.
Priorities and questions until our more final discussion. Yeah. I was just wondering why bacterial will found in high tunnel.
Yeah, so our best guess is that so I should start by saying bacterial wilt acts because a mound of bacteria gets clogged in the xylem of the plant tissue, and as the plant transpires, it loses a lot of water and can't pull up that water because the xylem are clogged. And we think that in the high tunnel, it's a much drier environment, much hotter, and so the plant is transpiring more and can't pull that water, so it's knocked out much more quickly. The actual incidence of bacterial wilt is probably the same in the open field and the high tunnel. It's just that the symptoms of bacterial wilt are much greater in the high tunnel.
I'm curious about that too. I've grown a fair number of cucumbers in tunnels. So did you actually have that early bacterial wilt? Did you culture bacteria out of those plants?
No.
Bill, can you repeat the question?
He was wondering if we cultured the bacteria out of the plants to confirm that it was Erwinia that causes the bacterial wilt. We didn't. We just recognized that the symptoms we were seeing were pretty classic symptoms of bacterial wilt, and so